The last couple of weeks, we've had some fun. We had Smitty 2 weeks ago, and last week we showed people this. This was a little ultrasonic detector made out of an Arduino. It was an $8 device that allowed you to set parameters so you can see exactly how far away something is from the sensor. This week, we wanted to continue with that because Arduino has been one of our best topics ever. People are very interested in this. They really want to build it because it's a nice combination of hardware and software. I mean, do you find that? I mean, I've learned that some people who would be turned off by straight software development perk up whenever they can find something that they can actually touch.
Yeah, absolutely. I think anytime you get your hands dirty with something and kind of get in actually doing something, you're going to learn a lot more because you're going to run into problems and then you're going to try to fix them and you're going to find solutions for those problems and you end up learning more in that sense.
Right, right. We did do a project not too long ago where we controlled a very simple set of lights. This was the episode that I had with Smitty using an analog potentiometer. And what the Arduino would do is it would use its analog pin to read the value of resistance from the potentiometer, actually the amount of voltage that was making it through, and then it would set conditions based on that value. Well, that's one way to get input into an Arduino. Another way was using an ultrasonic sensor. But today, we want to play with this. This is a PWM encoder. What PWM stands for is pulse width modulation. Lou, have you played with PWM at all?
Yeah, absolutely. You know, it's a way to kind of vary your encoded. You actually use encoded message to kind of vary the pulse signal.
Exactly. And so in broad strokes, what PWM does versus analog, while analog, let's say this is 0 volts and 5 volts, what that potentiometer would do is it would allow me to get from 0 to 5 or 5 to 0 based on where the potentiometer was held. PWM doesn't do that. What PWM is, it takes the value from the potentiometer. So it's already doing the translation from the analog potentiometer, and it encodes it into a PWM signal. And what a PWM does is every cycle, every clock cycle, has a low and a high. And that's when the bit is on or off.
Right.
Theoretically, it's cleaner because analog can be a little indeterminate. PWM, based on, of course, how good the encoder is, can give you a bit more accurate of a signal that propagates better over distance, which is a problem with analog. I mean, if you've ever tried controlling an analog signal from a long distance, you get a lot of fluctuation, you get a lot of discrepancy, right? I mean, that's typically what happens.
Right. Attenuation you get out of it. And then one thing with the idea here is, you know, the signal you can have in some of these little microcontrollers is, like you said, is a high or low, 5 volts or low volt or ground. And the idea is instead of trying to vary how high or how low it goes, it's really all you're doing is time, right? So then, and that's really easy to do when it comes to a microcontroller.
Exactly, and that's precisely what you're going to do with PWM. And that's exactly how we're going to read a PWM encoder with an Arduino. I can measure for any given clock cycle how long the signal stays high versus how long it stays low. Or conversely, if I wanted to, I could measure how long it stays low versus how long it stays high, which is essentially all PWM is. Now, like all of our other projects with Arduino, let's give you a part list really quickly. Here's 4 quick links for you to get all the pieces that we're going to be using in today's project. The first, of course, is the Arduino Uno. Now, this is one that I found. This is 361. You can find them really, really inexpensively on eBay. In fact, I just bought a set of 10 of them for $2 American, like $2.21. I also bought some minis, which use the same Atmel chipset, just for some specialized projects. But I would say if you're going to start to get into Arduino, because they're so inexpensive, because you can get these for anywhere between $2 to $4, go ahead and buy yourself a set, at least 5 of them. You will not waste them, and it's much nicer than having to disassemble your projects each and every single time you're done. The second piece I would suggest is a breadboard, and a breadboard looks a little something like this. Oh, I just disconnected my Arduino. This allows you to use jumpers to make temporary connections. So instead of soldering wires, you can jump in a connection. So you could test it, see if this is the right way that you want to do it. It's also a really good way to make temporary circuits before you permanently solder something. Now, what the Arduino would cost you between $2 and $4. That set that I showed you is going to cost you, what, $750. Now, the nice thing about using a breadboard is it's kind of a universal thing. So if you start looking at schematics on the internet,
reusable.
Yeah, exactly. They're reusable. The next 2 parts are really up to you. I like this. This is a pixel stick. It's an 8 LED WS2812, and this is a RTF pixel circle. This is a 26 LED WS2812. Both of these are from Ready to Fly Quads. The pixel stick is $325, and Kara, if you go to that website, yeah. So I bought a bunch of these, and then the RTF pixel circle is $10. Now, again, you can buy these much cheaper on eBay, and there's a good chance that you're going to get a decent value. The only reason why I use RTF for most of my lighting parts is because I know Paul Baxter. I have never gotten a bad part from him, and the people who have gotten bad parts from him, he's always replaced. He actually tests his stuff before he sends it out. I don't like buying what I think are cheap parts and then finding that they are broken and I can't get them replaced. So that's just me.